All right, let's get into it. Today, we're unlocking what I like to call a mathematical superpower, algebraic factorization. Now, I know it might sound kind of complicated, but trust me, it's your secret weapon for crushing equations and acing those tougher math classes. Let's dive in.
Yes, I am talking to you. Think of yourself as the hero of this story, the genius who is about to master a totally fundamental skill. So get ready, because we're about to make algebra click for you like never before.
So, what even is factorization? Okay, picture this. You're at the crazy busy Oshodi market, and there's this huge crate of, well, everything. A smart vendor doesn't sell the chaos, right? They sort everything into smaller, neat packages. That's exactly what we're doing here, taking a messy-looking algebraic expression and breaking it down into its simplest, multiplied parts. It's all about finding order in the chaos. All right, first challenge on deck. This is all about learning to see the patterns. Once you can spot them, factorization becomes second nature, super fast. Let's start with the most common one.
Okay, let's ease into it with the most common type, finding a common term. And I love this analogy. Think of it like factoring out the kalishi. If you've got two different snack packs and they both have kalishi in them, then kalishi is the common factor. Our job is just to pull that common kalishi out.
Okay, let's put it into practice with a super simple one, 5p plus 5q. So, first step, you got to spot what they both have in common. And here, it's obviously the number 5, right? We just pull that 5 outside of a bracket, and what's left inside? The p plus the q. So the result is 5 times p plus q. Simple as that.
Okay, so what happens when there isn't one single thing common to all the parts? Well, sometimes you got to get a little clever and group things up first. It's just like packing a box. You put all the phones together and all the chargers together before you pack the main crate.
All right, check this one out. We're going to group the terms that have something in common. So we'll put 3m with 3p and pq with mp. Next, we factorize each of those little groups. And here's the magic trick. Look what just appeared. A new common factor, the whole bracket, m plus p. So we factor that out, and it leaves us with our final answer, m plus p times 3 plus p. Okay, you are going to love this one. This is a massive shortcut. It's like a mathematical law, something you can always count on. Whenever you see one perfect square minus another perfect square, there's a special, predictable way to factor it. No long calculations needed. So let's see how this works with x squared minus 49. It fits the pattern perfectly. Our a is just x. And since 49 is really 7 squared, our b is 7. All we do is plug x and 7 right into that formula, a minus b, a plus b, and we get our answer, x minus 7, x plus 7. That's it. Done.
All right, here's another pattern you'll want to keep an eye out for. It's a 3-term expression. We call that a trinomial, but it's a special one. It's what you get when you take a simple bracket, like a minus b, and you multiply it by itself. If you can spot this pattern, you can factorize it in a heartbeat.
Okay, let's run through the checklist here for m squared minus 10m plus 25. First up, is the first term a square? Yep, m squared is a square. What about the last term, 25? Well, that's 5 squared. So far, so good. Now for the final test. Is that middle term negative 2 times our m times our 5? Yes, it's negative 10m. It's a perfect match. So the answer is simply m minus 5 squared.
All right, you've totally nailed the simple expressions. So let's level up. Challenge number 2, quadratic expressions. Now for this, we've got this amazing visual tool that's going to make it all so much easier. I call it the quadratic box.
See, look at this and you're thinking, how do we tackle an expression like x squared plus 7x plus 12? It's not a difference of 2 squares. It's not a perfect square. Nope, this needs a whole different approach. And it all starts with a little puzzle. Okay, here's the secret sauce. It's a 2-number puzzle. We're looking for 2 numbers that multiply to get our last term, which is 12. At the same time, they have to add up to our middle number, which is 7. So what could they be? Give you a second. Got it? It's 3 and 4. 3 times 4 is 12, and 3 plus 4 is 7. Now we have our magic numbers. And this is where our box comes in. This thing is awesome for keeping it all straight. We pop the x squared in the top left corner, and the 12 goes in the bottom right.
Then, those two magic numbers we just found, the 3 and the 4, we use them to split up that middle term into plus 3x and plus 4x. Pop those in the empty squares. Now the box is going to do the rest of the work for us.
And bam! Look at that! The factors are just revealed. They're sitting right there on the outside edges of the box. You've got x plus 4 on one side and x plus 3 on the top. That's it. That's your answer. X plus 4, x plus 3. The box makes it so visual and simple.
All right, time for the final challenge. This is where the rubber meets the road. We're going to take all these awesome skills and actually apply them to real-world situations. This is where you prove you've mastered this, by turning everyday language into the language of algebra.
Okay, let's check out a real-life problem. Amaka is designing a rectangular banner, and its area is 3x plus 15. Now, what do we know about the area of a rectangle? It's just length times width, right? So that means the length and the width have to be the factors of the area expression.
So, to solve this, it's a simple two-part mission. First, we translate the words into math, which is already done for us. Nice. Area equals 3x plus 15. Second, we unleash our new factorization skills to break that expression down.
Okay, so let's look at 3x plus 15. What's the common factor here? It's 3, right? We pull that out, and what are we left with? 3 times x plus 5. And since we know area is length times width, the possible dimensions for her banner are 3 and x plus 5. How cool is that? We just used algebra to solve a design problem.
And there you have it. Just like that, you've conquered all 3 challenges. You've gone from the very basics to quadratics, all the way to word problems. You've put in the work, and now, mastery is achieved. Isa dot.
So, let's just take a moment to appreciate your new mathematical superpowers. You can now look at simple algebraic expressions and just break them down. You've got the quadratic box in your toolkit to handle those tricky quadratics, and you can translate word problems into math and solve them. That's huge.
Think about it. You now have this incredible skill of taking something that looks really complex and breaking it down into its simple, manageable parts. And that ability, that goes way beyond a math class. So I'll leave you with this question. Now that you've mastered the breakdown, what are you going to build next?